So here we have a function defined by 4x minus 1 divided by 2 times the square root of x minus 1. We need to find its limiting value when x approaches 1/4. So the first job will be to substitute for the value of x into the given function, and we'll find that the given function will return us the value 0 over 0, which is going to be an indeterminate form. Now what we're going to do, we're going to factorize the numerator first. So let's begin with that. So we have limit x going to 1/4. So this 4x can be rewritten as 2 times the square root of x whole squared, because squaring 2 root x is going to give us 4x, minus 1 can be rewritten as 1 squared divided by 2 root x minus 1. Now what we can do, the numerator has the form a squared minus b squared, which is an identity that can be expressed as the product of a minus b and a plus b. So we have 2 root x minus 1 multiplied to 2 root x plus 1 divided by 2 root x minus 1. So we see that the 2 root x minus 1 is a factor common to both the numerator and the denominator. So we can cancel it out, and that leaves us with limit x going to 1/4, 2 root x plus 1 in the numerator. Now we are going to substitute the value of x, so that will give us 2 times square root of 1/4 plus 1, which is going to be 2 times square root of 1/4 is going to be half plus 1, and 2 times half is 1. So we have finally 1 plus 1, which is equals to 2. So 2 is going to be the limiting value of the given function when x approaches a quarter. So we need to find the limiting value of the given function when x approaches 0. So the first thing first, let us substitute for the value of x. So that will give us a plus 0, which is simply going to be a. So we have a squared minus a squared in the numerator divided by 0. So that gives us a 0 over 0. So this is an indeterminate form. Now we are going to factorize the numerator. So our numerator is in the form of an identity a squared minus b squared. So this can be expressed as the product of a plus x plus a multiplied by a plus x minus a divided by x. So we have limit x going to 0. So a plus x plus a is going to give us 2a plus x multiplied by simply x. The a and a gets cancelled out, divided by x. So the x and x is common to both the numerator and the denominator. They cancel out. Now we are left with x going to 0, 2a plus x. Now we are going to use the limiting value of x, which is 0. When x approaches 0, we have 2a plus 0, and that gives us 2a. So this is going to be the limiting value of the given function when x approaches 0. So here we have a function given by x squared minus 16 over square root of x minus 2. So this is a function which limiting value we need to find out when x approaches the value 4. So let us begin by first doing a direct substitution. So we have 4 squared minus 16 divided by the square root of 4 minus 2. The 4 squared will give us 16. So we have 16 minus 16 in the numerator divided by the square root of 4, which is 2. So we have 2 minus 2 in the denominator. So that will give us an indeterminate form, which is 0 over 0. Now what we have to do, we are going to factorize the given function. So let's begin factorizing the numerator. So the numerator can be rewritten as x squared minus 4 squared divided by the square root of x minus 2. So this will be equals to limit x going to 4. So now we're going to apply the identity a squared minus b squared. So we have x squared minus 4 squared, and that will translate to x minus 4 multiplied by x plus 4 divided by the square root of x minus 2. Now we can further factorize the factor x minus 4. So we can rewrite it as square root of x whole squared minus 4 can be written as 2 squared times x plus 4 divided by the square root of x minus 2. Then we can factorize the x's we can factorize square root of x squared minus 2 squared as square root of x minus 2 times square root of x plus 2 times x plus 4 divided by square root of x minus 2. So the square root of x minus 2 is the common term, is the common factor in both the numerator and the denominator. So we cancel it out, and rewriting the function, that gives us limit x going to 4. Now we are left with square root of x plus 2 times x plus 4. Now we're going to do a substitution. So we have square root of 4 plus 2 multiplied to 4 plus 4. So square root of 2 or 4 will be 2. So we have 2 plus 2, which is 4, multiplied to 4 plus 4, which is 8. So the limiting value will be 4 times 8, which is 32. So here we have a rational function whose limiting value we need to find when x approaches the value 2. So we do a direct substitution, and that will yield 0 over 0, which is an indeterminate form. So this means x minus 2 is a factor common to both numerator and denominator. So we begin by dividing the numerator x cubed plus 3x squared minus 9x minus 2 by x minus 2. So we're going to perform the synthetic division. So that has been already covered in work set number 1 and worked out problem number 2. So you can have a look at that. I'm going to straight away write the factors of the given polynomial. So this will be equal to x minus 2 times x squared plus 5x plus 1. Then we divide the denominator, which is x cubed minus 6 by x minus 1. So we have x minus 2 times x squared plus 2x plus 3. So now our limit x going to 2 becomes x minus 2 multiplied by x squared plus 5x plus 1 divided by x minus 2 times x squared plus 2x plus 3. So we cancel out the common factor, which is x minus 2, leaving us with x squared plus 5x plus 1 divided by x squared plus 2x plus 3. So now we are going to substitute the value of x, and that is going to give us 2 squared plus 5 times 2 plus 1 divided by 2 squared plus 2 times 2 plus 3, which will be equals to 4 plus 10 plus 1 divided by 4 plus 4 plus 3. So the final limiting value of the given rational function will be 15 over 11 when x approaches 2. So here we have a function given as x cubed plus 1 over x plus 1. We have to find the limiting value of this particular function when x approaches negative 1. So we do a direct substitution. So we have negative 1 cubed plus 1 divided by negative 1 plus 1. So cube of a negative 1 gives us negative 1. So we have 0 over 0, which is an indeterminate form. So now we have to factor out x plus 1, which is a common factor in both the numerator, must be factored out. So that gives us limit of x going to negative 1. Now x cubed plus 1, this has the form a cubed plus b cubed, because 1 can be rewritten as 1 cubed. So this is equals to a plus b times a squared minus ab plus b squared. So we're going to use this identity, and that will give us x plus 1 multiplied to x squared minus x plus 1 divided by x plus 1. So we see that x plus 1 is the common factor in both the numerator and the denominator, so they get cancelled out. Now we have limit x going to negative 1, x squared minus x plus 1. Now we're going to substitute the value of x, so that would be negative 1 squared minus of minus 1 plus 1. So we have negative 1 squared is positive 1, negative 1 times negative 1 will be positive 1 plus 1. So this is equals to 3. This is the limiting value. So we need to find out the limiting value of the given rational function when x approaches 5. So the first thing will be to do a direct substitution. So we have 5 squared, which is 25, minus 9 times 5, which is 45, plus 20, divided by 5 squared, minus 6 times 5, plus 5. So this is giving us an indeterminate form of 0 over 0. So that means we need to factor out x minus 5 from both the numerator and the denominator. So let us begin by factorizing the numerator first. So we have x squared minus 9x plus 20. So we know that the factors of 20 will be 5 and 4. So we're going to use 5 and 4 to split the middle term, that is negative 9x. So we have x squared. So negative 9x can be written as negative 5x minus 4x plus 20 divided by x squared. So the factors of 5 will be 5 and 1. So negative 6x can be written as negative 5x minus x plus 5. So that will be equals to limit x going to 5. Taking x as the common factor, in the first two term we have x multiplied to x minus 5 minus 4 multiplied to x minus 5 divided by x times x minus 5. Taking negative 1 as the common factor, we have x minus 5, which will be equals to limit x going to 5, x minus 5 multiplied to x minus 4 divided by x minus 5 times x minus 1. So we have x minus 5 as the common factor in both the numerator and the denominator. So we are going to cancel it out, and that is going to leave us with limit x going to 5. We have x minus 4 in the numerator divided by x minus 1. Now we're going to substitute the value of x with 5. So we have 5 minus 4 divided by 5 minus 1, which is going to give us 1 over 4. So this is going to be the limiting value of the given rational function when x approaches 5. So here we have to determine the limiting value of the given function when x approaches 1. So that will be equals to 1 minus 1 raised to the power of negative 1/3 divided by 1 minus 1 raised to the power of negative 2/3. So this is simply going to be equals to 1 minus 1 divided by 1 minus 1. So we have a 0 over 0 form, which is an indeterminate form. So now we'll factorize the denominator. So we can rewrite the given function as 1 minus x raised to the power of negative 1/3 divided by, so we're going to rewrite the denominator. So 1 will be, or we'll come back to 1 for the exponent of 1. So what we can do, the second term, which is x raised to the power of negative 2/3, this can be rewritten as x raised to the power of negative 1/3 squared. So that means the exponent of x is negative 1/3 and we square it. That's fine. So we just keep 1 squared here. So this will be equals to the limit x approaching 1, 1 minus x raised to the power of negative 1/3. Now we have the identity a squared minus b squared in the denominator. So we can rewrite this as 1 plus x raised to the power of negative 1/3 multiplied by 1 minus x raised to the power of negative 1/3. So we see that 1 minus x raised to the power of negative 1/3 is the common factor. So we cancel it out, and that leaves us with limit x approaching 1, 1 divided by 1 plus x raised to the power of negative 1/3. Now we substitute the value for x. So we have 1 divided by 1 plus 1 raised to the power of negative 1/3. So 1 raised to the power of any x value, any exponent is always 1. So we have half. So this is going to be the limiting value of the given function when x approaches 1. So we have the rational function x raised to the power of 4 minus 16 divided by x minus 2. So we have to find its limiting value when x approaches 2. So the first thing will be do a direct substitution. So we have 2 raised to the power of 4 minus 16 divided by 2 minus 2. So 2 raised to the power of 4 gives us 16. So we have 16 minus 16 in the numerator divided by 0. That gives us an indeterminate form, which is 0 minus 0. Now what we're going to do, we are going to factorize the numerator, which is x raised to the power of 4 minus 16. So this can be rewritten as x squared whole squared minus 4 squared. So we apply the identity a squared minus b squared. So that will give us x squared plus 4 multiplied to x squared minus 4. So 4 can be again rewritten as 2 squared. On further simplification, we'll get x squared plus 4 times x squared x minus 2 times x plus 2. Now we are going to substitute this value into the numerator and then determine the limiting value. So we have x approaching 2. So x squared plus 4 times x minus 2 times x plus 2 divided by x minus 2. So we cancel the common factor, which is x minus 2, and that leaves us with limit x going to 2, x squared plus 4 times x plus 2. Now we use the limiting value of x, which is 2. So we have 2 squared plus 4 times 2 plus 2, which is equals to 8 times 4. So the limiting value of the given rational function is 32. So here we have a rational function, which is a biquadratic polynomial divided by a cubic polynomial. So we have to find the limiting value of this given function when x approaches 1. So when we substitute for the value of 1, we will get an indeterminate form, which is 0 over 0. So this means we need to factor out x minus 1 from both the numerator and the denominator. So let us begin by dividing the biquadratic polynomial by x minus 1. So we are going to perform a synthetic division. So the factors of x raised to the power of 4 minus 3x cubed plus 2 will be x cubed minus 2x squared minus 2x minus 2 multiplied by x minus 1. Now we are going to factorize the denominator, the cubic polynomial, by dividing it with x minus 1. So we are going to perform synthetic division again. So the factors will be x minus 1 multiplied by x cubed minus 4x squared minus 1. Now we are going to substitute this value back into our function. So that gives us x minus 1 multiplied by x cubed minus 2x squared minus 2x minus 2 divided by x minus 1 times x cubed minus 4x squared minus 1. So we cancel out the common factor and then substitute the value of x. So we get 1 cubed, which is 1, minus 2 times 1 squared, which is negative 2, minus 2 times 1 is minus 2, minus 2 divided by 1 minus 4 minus 1. So we have 1 minus 6 divided by the 1 will get cancelled. We have negative 4. So this is negative 5 over negative 4, which is going to be equals to 5 over 4. So this is going to be the limiting value of the given rational function when x approaches 1.